Hello everyone, myself Jugal Dinesh Mandan as a assistant professor from Department of Quality Assurance from Sri Vile Parle Kelawani's Mandal's Institute of Pharmacy, Dule. So this is the disclaimer for my presentation I'm going to present today. Today, today, the topic of discussion is acid-base titration, in which I'm going to cover what do you mean by titration, acid-base titration, classification of titration, and some pictographic diagrams to understand easily. So let me begin. Titration. Titration, known as titrimetry, is a common laboratory method of quantitative chemical analysis that is used to determine the unknown concentration of an identified analyte. Titration may be also called as volumetric analysis, in which a reagent called as a titrant or titrator is prepared as a standard solution whose concentration is known and the volume of titrant reacts with the solution of an analyte or a titrant to determine the concentration. The volume of titrant reacted is also called as titration volume. So next, endpoint or equivalence point. Equivalence point is the theoretical completion of a reaction, the volume of added titrant at which the number of moles of titrant is equal to the number of moles of an analyte. Endpoint is what is actually measured. For a physical change in a solution is determined by a use of an indicator. There is always a slight difference between the theoretical change and as well as the practical endpoint of a titration. The error which occurs between during difference between the theoretical and practical is also called as titration error, and it is always indeterminate. Next, the above is a pictographic image of a titration assembly in which the titration setup is done. For example, we are using burette through which a titrant is passing by to a conical flask in which it consists of an analyte titrant. The reagent is always a known concentration whereas also known volume, and the analyte or titrant has a known volume but there is a known unknown concentration which we have to standardize for a further reaction. So, what is acid-base titration? An acid-base titration is a determination of a concentration of an acid or base by exactly neutralizing the acid or base with an acid or a base of a known concentration. As there is an involvement of acid and base, it is also known as a neutralization titration. The acid-base titration are used for many applications. For basic example are like they are used as a physical determination for physical dissociation constant, whereas also the acid constants through a pH titration graph. These titrations can also find percentage purity of chemicals. Alchemetry and acimetry both are universally important by using acid-base titration. Alchemetry is a specialized analytical use of acid-base titration to determine the concentration of a basic substance, whereas acidometry, which is also known as acidometry, is the same concept of specialized analytical acid-base titration but for an acidic substance only. The below are the examples of acid-base titrations. The first example is when hydrochloric acid reacts with sodium hydroxide, it gives sodium chloride and water as byproduct. The next is for weak acid, in which weak acid used is acetic acid plus sodium hydroxide, which gives sodium acetate as a product and water as a byproduct. Next, this is a pictographic assembly of an acid-base titration, in which you can see there are multiple conical classes which shows the reaction for a known concentration added with the unknown concentration, which shows the change in chemical color, which shows with use of indicator we are using. For example, is an acid-base titration. Most universally used indicator is phenolphthalein. As we added phenolphthalein in the second conical flask, then while we on the cork for burette initial, we notify the initial reading which is shown here, and then we hold on until the color changes. When the color changes to pink completely, when they stop the knob and we see the final reading. For example, if it's a colorless solution, we will go for the lower meniscus, and whereas if it is a colorful solution, we have to go for the higher meniscus. Okay, next. Classi- Classification of acid-base titrations. There are mainly four types of acid-base titrations, and acid-base titration are also called as aqueous titrations. So the classification is as above: strong acid versus strong acid versus weak acid versus strong base, or weak acid versus weak base. So we begin with the strong acid versus strong base. Here are strong acid reacts with a strong base to form salt and water. The reaction of this type is very fast and also complete. The reaction happens in stoichiometric means. At the end of the reaction, no molecule of acid or base exists, as every molecule in the reaction has completely reacted to the form a salt. Hence, the end point or equivalence point is precise and sharp. The reaction has an example like hydrochloric acid plus sodium hydroxide when reacts with each other gives salt, which is sodium chloride plus water. Example of these types of acid are hydrochloric acid, sulfuric acid, nitric oxide, hydrobromide, perchloric acid, H3PO4, etc. The examples of strong bases are sodium hydroxide, magnesium hydroxide, aluminum hydroxide, etc. Next, the second is strong acid versus weak base. Here, a strong acid reacts with a weak base to form salt and water. But since the reaction uses strong acid, the pH at endpoint will be towards acidic, that is below 7. Here, the salt formed, for example, ammonium chloride, is slightly acidic in nature. So, indicators changing color at lower pH are employed. During reaction, known concentration of strong acid is taken in burette, allowed to react drop by drop with the base in the beaker. And there is the use of indicators also, which helps to maintain the concentration universally. The reaction is when hydrochloric acid reacts with ammonium hydroxide, it gives ammonium chloride plus water. Next, third one is weak acid versus strong base. Here the reaction happens when a weak acid and strong base reacts. The weak acid is taken in a beaker and known quantity of strong base is dropped from a burette till the endpoint or equivalence point is attained. The salt form is slightly basic in nature so that the pH of the endpoint is above 7. As a strong base is used, the main reaction which results is mostly on the basic side only. The indicator used is one with change of color at higher pH. So while using indicators, we have to go through the pH also, because the reactions which are going to use, we need to monitor the indicators too. The reaction here used is acetic acid, which is a weak acid which reacts with strong base, that's sodium hydroxide, which gives sodium acetate plus water as a byproduct. Fourth, and the last one is weak acid versus weak base. Here, both the acid as well as base are weak in nature, so mostly they are avoided due to imprecise endpoints, or you can say unpredictable results. At the endpoint, the pH will be 7 theoretically, but cannot be measured precisely as that in strong acid and strong base case. The first one. An extra amount of titrant is needed to reach the endpoint due to imprecise reactions which are attained as a result. The reaction for the example is we are using carbonic acid with ammonium hydroxide, which gives ammonium hydroxide plus water. Here the endpoint is neutral as the salt is neutral, but due to excess titrate added, the pH can be in favor of base, which is ammonium hydroxide as a result. Thank you everyone.